Good morning. I'm going to start with a bit of audience participation because I know people like that, especially early in the day. But don't worry, it's not that bad. I just want to know how many people here have been responsible for supporting a production system? Which is why you're here, of course. Okay, so this probably looks familiar. With the threading, I think this is something like 400 email alerts. It's very hard to work out what the problem is here. And after I took this screenshot, I actually checked, and these aren't alerts for my servers. Some other team copied some config, put my mailing list on it. They're not even for my stuff. Another example in Slack. The problem when things go wrong is sometimes you get told about it a lot. So, in the space of an hour, we couldn't pretty much do anything else in this channel other than look at things telling us something was wrong. Final example, and this is my phone on the day of the Dyn DDoS attack. So the FT uses Dyn. My team weren't fixing it. There was a sort of shared services team that was looking at Dyn, but I was getting a consistent number of alerts from PagerDuty, and I couldn't stop them because PagerDuty uses Dyn, and I couldn't get into the GUI and do anything to stop it. So I was actually sat in a pub going 84, 94. So knowing when there's a problem isn't enough. What you need is a succinct, understandable alert that tells you what you need to do. You only want an alert when you're going to take action. Anything else is just noise. But how do you get there? So, as Dan said, I am a principal engineer at the Financial Times, and I lead the content platform work there. And about 3 years ago, we started building a new version of that platform, and we're using a microservices architecture. And we started off building a lot of Java microservices, and then we moved to Go because it's a lot smaller, the kind of services we're writing. Pretty much now Go is our preference. We are running Docker on CoreOS on AWS. We have multiple data stores, so we've got MongoDB, Neo4j, Elasticsearch, and we're using Kafka as our messaging queue. And we currently use Fleet, Vulkan and home-written services to do our orchestration and cluster management, but we are moving to Kubernetes currently, as you would expect. So this is a very simple view of our architecture. And there are 4 main concerns that we have. We take in content from all of the different content management systems in the FT, and that might be articles, blog posts, videos, and we transform it into a common format. And as part of doing that, we run it through a concept extraction pipeline to work out what companies and people are mentioned in that content. So we can say this is about Apple, it mentions Samsung. But to do that, we need to load all of the information about companies and people. So we have millions of companies, millions of people that we know about. And finally, we make all of that available through APIs. So monitoring this system, talking about monitoring this system is talking about what it's like to move from monitoring a monolith to monitoring microservices. But it's also a little bit about what it's like to do DevOps. Because with microservices, you can't really spare the time to hand this stuff over to operations every time you change it. So you are going to be doing at least some level of support, which means you are the people that will feel the pain when you write shoddy monitoring and alerting. So microservices basically make it all worse. I'm sure you all know what a microservice is. It's an efficient device for transforming business problems into distributed transaction problems. The services themselves are simple. I actually do really like working with microservices because I can take 10 minutes and understand any of the services in the system. I can make changes to the architecture fairly easily. I deploy independently, quickly, reverse things out if anything goes wrong. So yeah, microservices are great, but there's a lot of complexity around them. Now your challenge is to understand how all of the microservices interact with each other to produce your functionality. So why do they make monitoring harder? Well, it's a really simple answer. There's just a lot more services. So when I was preparing this talk, I went and counted how many services we had running in production. So we have 99 functional microservices. So 350 running instances once we've got 2 production regions, resilience for almost all the services. Interestingly, we've got 52 non-functional services, by which I mean things that do backups, configuration, deploying, provisioning, load balancing, monitoring. So that's a ratio of 2 to 1, which is actually was quite surprising to me. But we have 568 separate services. So if you monitor each of those services, just one check once a minute, that's over 800,000 checks that you're running a day. And that's one check every minute. That's quite a lot. But that's just talking about functional checks. So what about system checks? Well, when we started work on this, we deployed all our services into separate VMs. And for each of those VMs, we monitored 20 different things like CPU usage, free disk, free memory, TCP connections. And when you work that out, it's over 16 million checks a day, if we carried on like that. And what that means is a 1 in a million issue hits us 16 times a day. And that's a bit mind-blowing to think about that. So we don't actually do that. We basically thought, okay, we need to use containers, reduce the number of VMs we have. We reduced the number of checks because quite a lot of those system checks were things that I wasn't going to fix. I was going to see an alert and then contact our networks team and ask them to fix it. But we actually have 92,000 system checks per day, but it's still, the total number of checks we're running a day is nearly 1 million. So there's a lot of checks, and it's a distributed system. We're not doing in-process calls anymore. All of our calls are over the network, which means that network latency, other services being redeployed. There are lots of reasons why your checks might fail, once or many times. And the final thing to say is that services aren't completely independent. So you might aim to do most of your communication asynchronously through messages, but if you've got a service that writes to a database, it's likely making that call synchronously. And we also have, because we store different parts of our data in different data stores, we might take content out of a document store and the metadata of that content out of a graph database. And that means that we end up with a system that might look like that. And when something goes wrong to one of the data stores, you definitely get an alert from the service that's using it. But if you aren't clever in how you do alerts, you get an alert from all the services that use that service. And when that happens, this is what it feels like. So you need to change how you think about monitoring if you're doing microservices. You need to take the time to do it properly. So how can you make it better? Well, we've been doing it now, as I said, for nearly 3 years. So I can tell you some of the things that have worked for us. And the first thing that I want to say is that you need to build a system that you can support. And you really want to do that from the beginning, because no one wants to turn around a year in and go, right, I have to go to 50 plus microservices and make a change in all of them to give me the thing that I actually find out I need. So there are obviously basic tools you need to support any system. So for example, you need logging, but you can't jump onto a box and tail logs anymore because the thing that you're interested in probably happened across 5 different services on multiple different boxes. So you need log aggregation. And we do that in Splunk. And Splunk's pretty handy for us because you can do aggregate queries, so you can find out what's your 95th percentile response rate, but you can also track individual events. But now it's not about just writing the log to disk. So, that you expect to have work. But when you're writing from a Docker container to the file system and then sending it out to some cloud service that's going to import it into log aggregation, things go wrong. We discovered, we're running our Docker containers as systemd services. We discovered that there's a limit of 1,000 log lines per 30 seconds by default. If you don't change that, you lose logs. It's surprising how long it takes you to realize you've lost a lot of logs, if it's kind of intermediate. And if you're setting up an alert that says, did we have any server errors in the last 10 minutes? Well, if your logs don't make it there until 10 minutes late, your alert never fires. You don't know what happened. So logging's important, but you need to think about all of the steps that are now put in place if you do log aggregation. Monitoring is also obviously something you need to do. When we started out with this service, we used Nagios. And it's a really simple reason we used it. We were using the FT's platform as a service, and it gave us Nagios for free. It was quite opinionated, though. So we could provision and deploy a VM to a new VM in 10 minutes, and we'd get these 20 system checks. But there were some limitations. There wasn't a service level view. So if I had resilience for a particular service, and I did a zero downtime deployment, it wasn't a zero alert deployment, because Nagios didn't know that they were related and would alert for each one as I deployed. And that is really annoying, because it means when you do a deployment, you have to go and put things in maintenance mode, or you have to go and acknowledge stuff, or else your first-line operations team phone up and go, what's just happened? And lots of the checks that had been done by default were things that I was never going to fix. And I really hate getting alerts that I'm not going to fix, because it's just annoying. So when we moved to the container stack, we didn't get Nagios by default. So we were basically thinking, well, what do we really want to do? And it was interesting hearing Jonas talk on Monday about how microservices are a system. You know, your set of services is a system. Because we've taken that approach. We have a single aggregate health check service that looks across all of the microservices in our system and has some logic in it to say whether we're healthy or not. So we care about each service. So as long as I'm able to serve from one of the nodes, I'm pretty happy. And so this is the output of our health check. And basically, we've got 2 of most of our services, and we'll only alert if we've lost both of them. We also care about our VMs, but we've decided to really minimize what we check, and we've written a service that just does things like check for disk free space, TCP. And if we have a problem, we add a new thing into this. So we're taking the approach of let's monitor stuff when we've seen that it's caused us a problem, rather than let's imagine all the things that might cause us a problem and monitor them. So the version checker at the bottom is checking the version of CoreOS that we're running. And the reason that's there is we stopped doing automatic deployments of the new stable versions because they weren't as stable as they were meant to be. But we also don't want to just turn around and say, oh, actually, we're really out of date. So we go sort of orange in a nagging way if we need to upgrade. So, and we do care about the unhealthy instances because you want to be resilient. But I care about this in a way that means please don't wake me up at 2 in the morning. If you could just like send me an email or a message that said this doesn't look completely resilient, that would be quite nice. When you've got this monitoring, we've got this aggregate health check, we do need to bring the information about that monitoring from our various systems together. So we've got 2 regions, we've got pre-production, which we also care about. And we needed to find some way of looking at it in one way. And this is not going to be an acronym you've ever heard of because it stands for Silvano's Awesome Warning System. And it was the first thing that we had maybe 3 years ago. And it was written by one of our integration engineers. He just turned up in work on a Monday morning, having just created this for fun. And it's using Blinky Tape, which is a programmable LED strip. And he's basically programmed it so it checks various different servers, and it goes red if there's something wrong. And if everything's okay, it's got like a Knight Rider blue light going back and forth because otherwise people tended to say, is it broken? And it used to run on a Raspberry Pi, which was quite cool, and we got featured on the Raspberry Pi blog, but don't tell them, but it broke, and now it's just running on an old Windows machine, which makes it not cool. So why did he do that? Well, the first thing was frustration about all these emails. He had a filter. He never saw them anyway, but it was just like, oh, it's so annoying. And then we had got screens up, but they were small, and the angle was bad, so you really struggled to see stuff. And then we had that really bad idea of having a carousel of things that we were monitoring. So what happens is you see red out the corner of your eye, you turn around, the page has moved on to the next page, and then you stand there just looking, waiting for the right thing to come around. So we didn't really like that. So having this up in the office, it's really obvious to everybody, and it's obvious to non-technical people. If it's red, someone will always come up to me and say, did you know that was red? It's also really good for demos because you can basically, if you're demoing resilience, you can take down a system and it goes red, and everyone in the audience thinks that's amazing, even though clearly I could do that like programmatically. So the next thing we had after SOARs is dashing, which is a framework that Shopify wrote, although I think they've stopped supporting it now. But it basically allows you to have a web page with widgets in of different colors. And you can write widgets of different types. The FT, all the things that the FT normally uses for monitoring are integrated with this. So you can call a Nagios box. You can look at the result of a pingdom check. We use pingdom for web URL monitoring. You can look at the result of a Jenkins job, and you can also call our aggregate health check. And this is my team's dashboard, and it's up on screens, and we don't rotate through. That's just above our heads all the time. But we also have, this is the FT's first-line operations dashboard. So they really like dashing, and if you don't have something shown on dashing, they will basically keep going on and on at you to write something that puts it up on there. And it is ordered in terms of importance. So the most important services, the ones that have to be up all the time, are in the top left, going down to the least important in the bottom right, and they are color-coded: platinum, gold, silver, and bronze. I don't know who decided that platinum and silver were 2 good colors to put on the same thing, because obviously they are entirely the same. But that's really useful. You can look at it and you can dig in. If you've got that open in your browser, you can go and click on and be taken to more information about it. So that provides a really good view of how healthy is my system right now. So talked about logs and monitoring. The third thing is graphing. And we started off doing most of our graphs off of logs. But actually, there's something a bit wrong with that because you're using a side effect of logs that people wrote for other reasons. So I think it's much better to decide the things that you care about and record them. So what are the metrics that you really want to know about? And so we thought, well, actually, we're going to start doing that. We have got Java and Go apps. There's a Go port of the CodaHale's metrics library. So it's really easy for us to have a very consistent view of metrics, whether we're writing we've got a Go app or a Java app. We export to Graphite, which I think you can agree is pretty ugly. But Graphite just receives all this stuff. You can then build stuff on top of it in Grafana, and Grafana is actually really nice to use. It's very quick to configure. The dashboards load really quickly. And this is a dashboard for one of our APIs. So we're interested in what's our error rate, what's the client error rate. You can add lots of different things. I took this screenshot, and then I realized that we appear to have swapped from one data center to another halfway through. It's quite easy to see. This is our system stats graphed. These are the things we tend to look at when something we know, we've got an alert, we know something's wrong, we can go and see, oh, was the CPU going up gradually or did it suddenly spike? And then finally, that aggregate health check that I showed you outputs information so we can see where things go wrong. So the top line here is our production environment, it's great. Bottom line is a team environment where they were trying out some sweeping changes that, as you can see, were really unsuccessful. But it's quite pretty. The interesting thing, and something that took us way too long to realize, is that if anything goes wrong in any of these things you're using to tell you about your system, you don't know the health of your system. So these need to be exactly as available as your system or more available. So if you're in a situation where if Splunk fell over at 2 in the morning, no one would fix it until 9, your system is not available overnight. Someone has to be able to support you for that. So you have these basic tools, but there are things you need to do to make them usable. So clearly, if you are doing metrics, you need to have some sensible metrics that you're recording. If you're doing log aggregation, you need something that will let you identify an event and all the things that are happening as part of it. So we use transaction IDs. So any service that we have in my platform has to look at incoming requests or messages for a header, X request ID, that will have a transaction ID. If none is supplied, the service will generate one. It is responsible for passing that on for any calls that it makes and for logging it in all the logs. So we've made it easy for the languages we use. So in Java, there's a servlet filter, and we use MDC to stick the transaction ID into thread local, and it just is output on all of the logs. For Go, there's an HTTP handler library, and we pass context around, which is we thought would be annoying, but it's actually not a big deal at all. But basically, what this means is I can go to Splunk and say, I know about this transaction ID, what happened? And the field is extracted, so you can do transaction ID equals blah. And that's really handy when you're trying to work out what went wrong. And it's really useful, therefore, to put the information about a transaction ID in all of your alerts, if you know it. For monitoring, you need your services to report on health. And the FT has a health check standard, so that if you've got a web service, you should have on __health, you should say whether your service is healthy. And it returns 200 if the service can run the health check, even if the health check's failed. I was on the wrong side of an argument about this, where I said well, it should return a 500. But the argument is 200 says I was able to run my health checks. And if you want to know whether a check failed, you have to parse the JSON that comes back. And the JSON looks like this. So generally speaking, it has a link to some guide that will tell you more about how you can fix it. It talks about what the technical impact is. It talks about what the business impact is. And we have a Chrome plugin to make it look a bit nicer if you're trying to look at it. And we can aggregate this stuff. And because it's a common standard, you can produce all kinds of tools that teams will use. And because you produce the tools, teams will do it because they get a benefit out of it. So the final thing I wanted to talk about with tools is it's really useful to know about problems before your client does. And I'm thinking particularly about publishing at the FT, because we don't do that many publishes a day. It's probably less than 1,000. And they tend to be grouped. And also, they tend to happen a lot after the development team has gone home. So people in our Manila office will publish a lot of articles late at night for the morning traffic. And I don't really want that to be when we find out that we deployed something that broke publishing. So what we do is we have synthetic publishing. We've got one old article. It's a real article. It's one that we think we're very unlikely for anyone to change for any reason ever. So it won't interfere with our monitoring. And we just republish it once a minute with a different timestamp. And then we just check to see if we've got the latest one. So what that will tell us is when publishing goes wrong, we'll know immediately. We don't have to wait until someone does it for real. And we've done that for quite a few of our publish flows. And I think we'll probably aim to do it for most of our things. It's kind of replaced acceptance tests for us because it's a lot easier to think about doing synthetic monitoring actually in a microservice architecture. So the first thing was about having building support in from the start. The second thing is working out what matters. What's the stuff that really matters? So it's the business functionality that you care about. So this is the FT's homepage. This list here is editorially curated. It's here are our top stories that you would be interested in. And I can guarantee that if this list is updated and you don't see it on the homepage in minutes, someone is going to phone me up. So that's what I care about. And we care about every single publish for our publishing because basically journalists really hate it when they write something and it's not available for people to read. So every single publish, we monitor and we say, okay, has it been published within a certain amount of time? We have a service that does this monitoring. It listens for the initial notification of publishing and makes sure that it's available through all our APIs within a set time period. And the dashboard lets us measure how we're doing for all of the things that we care about. For our APIs, we have a lot more volume. We're dealing with millions of requests a day, and we tend to look at percentile, so 95th percentile response rate. So we also care about errors. So response rate's important, errors are also important, and it's not just 500 errors because if you suddenly get an increase in client errors that you're getting, it's probably because you screwed up. So we released some code that made it, that basically said if you were going to do a search using our APIs, you had to provide a content type header application JSON. We'd never required that before. People had been quite happily searching for ages. So although it was HTTP spec compliant, we suddenly got a huge number of alerts, and we caught it because we were checking for that. And we have a dashboard for our read availability, and I'd like you to spot the obvious problem with this dashboard, which is, of course, that if your monitoring says 99.99, you're in a really good state. If your monitoring says 100, your monitoring is broken. I have no idea how I ended up with 100% on all of these dials, because that is suspect. The thing that's interesting about all of this is it's the end-to-end that actually matters. So we do back off and retry. So actually, if the first request, the first attempt to do something failed, but the second attempt worked, I don't care about the failure that happened first. And I don't want to get an alert about it, because basically the thing worked. So I might want to create a report so I can see what's going on with these things, but we did that, and actually what mostly happened is we never looked at it. So if it eventually works, we're generally speaking quite pleased. If we see a lot of failures, maybe we'll look into it. But you can go a long way without having to worry about that. The final thing, though, is to check all the services that are involved in a business flow, specifically the ones that are doing the monitoring of it. So you do want to know if the publish availability monitoring service is broken. You need to know because otherwise, again, you don't know whether your system's working. And the way that we do this is we categorize our services to say, well, they're involved in this business flow. And they can be involved in multiple ones. So I could say, well, when we publish a list of content, this service is part of that flow. And I can make a request to our health check to say, tell me the health of this particular slice of business functionality. And that means that your dashing can actually be divided up into specific different business cases. So people can say, content publishing is working, but list publishing isn't working. And that's really handy for everyone that's talking to you about the health of your system, because what they're telling you is information that really helps you narrow down on the stuff that matters. And our alerts are tied into that. They call these health checks with a category. So when we get an alert, we know what the thing is that's gone wrong. So my third point is about cultivating your alerts. You need to make your alerts good, because basically the person who's responding to this alert may never have done anything with this service. This may be completely new to them, or they may not have looked at the code for 6 months. It might be 2:30 in the morning when none of us are at our best and able to really work out what's going on. And it could well be you in the future. So you do this for future use benefit. So review it, make sure that it makes sense, make sure that links work, make sure that it's very clear what you need to do. So this is an example of a bad alert message that we used to have. So I like the title because it shows it was written by a Java developer. Method API response time 5M alert. 5M stands for 5 minutes because originally it ran every 5 minutes. It wasn't running every 5 minutes by the time I looked at this alert, but the name hadn't changed. It might result in articles not getting published. I don't know about you, but I don't care if it might. I want to know if it did. And it had this amazing technical impact section. It was a mandatory section, but people just put any old rubbish in there. Well, it might, you know, something's gone wrong. It doesn't help me at all. So we rewrote this. So now it has spaces, and it tells me that it's about failures of publishing from our method content management system. That's very, very clear. And I know which UUID, so I know which article was the problem. And I know which transaction, so I can tell if it was republished multiple times, and a lot of our articles get revised and republished, I can tell which thing was the problem. It's possible that I may not have to do anything because it's been republished since and it's fine. And then finally, there's a link to a runbook, and that runbook has more information, and you can change that separately from the alert. And in this case, the runbook has a link to a Jenkins job where you can stick the UUID in and republish. And the only reason we don't automate it is because our editorial department would like us not to. But it's really easy to recover, and anyone can do this. You don't have to know our system at all. So you need to make sure once you've managed to keep your alerts down and they're actually real things that you can't miss them. Because it's really annoying to have someone say, well, this thing's been read for half an hour. What have you been doing? And how you do that depends on your team. But what we've ultimately done is we have an OptCop rota where from our team of developers and testers, 2 at a time spend a week being the people who need to respond when things go wrong. And the reason we did this is because actually when you're deeply involved in design discussions or coding, you don't notice lights going off. So you need to have someone who's totally focused on, is that thing read? Has there been a message come into Slack? And when they're not doing the work on any support, they're doing small changes in tooling and stuff that helps us. So it's a little bit inspired by the Google SRE thing. So you have the OptCops, and you need to make sure that you're using the right communication channel to make it easy for them to pick things up. And obviously it's not email. But for us, you know, we're a bit hipster, we're using Slack. We were using it early. We do really like it, and we make sure that all of our alerts go into Slack. And we used to put them into our team channel, and I was a real advocate of this because my argument was, if you don't put them in the channel you're all in, people will just ignore it. And actually, if it's getting annoying to you, you have 2 choices. You either make sure you get fewer false alerts, or you basically improve your broken system. But I've changed my mind because it just gets in the way of other communication that you're having. So now we have a dedicated channel that's literally production alerts and responses to that. And so the description of the channel says who are this week's OptCops, so we know exactly who to go to, and they are in there talking about stuff. One of the things we do that I really like is we use emojis to react to alerts to say what we're doing. So it's there right with the alert. Normally we put eyes if we're looking at something, it's a green tick. If we've fixed it, it's a grey tick. If we didn't have to do something to fix it. We had to have a little bit of a formal agreement about the emojis because we had one too many cases of a dancing lady where hamster dance. And I'm just kind of like, I don't know what that means. It's really obvious that it's not enough to just get things back up and running. You need to work out what went wrong and try and stop it happening again. And one thing we do for our OptCops, we ask them to fill out failure reports whenever we have something that we think is interesting. So it doesn't require anyone else to tell us there was a problem. It doesn't mean that anybody had to have it had an impact on someone, but it's just, oh, well, this is interesting. How did we fix this? And we have a template so that people just have to fill in these sections. So the summary might say, Amazon S3 went down in US East 1. Health of our clusters would be probably screenshots of what happened for us in our metrics. And we talk about how we fixed it, we talk about the impact. In our case, we've got a second region, fantastic, and actions. And so maybe the actions would be, actually, our US region, everything went red and everybody worried, although we'd failed over fine automatically. So maybe we need to stop things going red when we're not serving traffic out of a region. And then what happened tends to be a lot of information to help us work out what happened. And we tend to get easily the timeline because We are in 2 locations, and our OptCops, we get 1 from each location. So actually, they're always talking in a Slack channel anyway. So we just can grab all of this information and put it straight into the report. So yeah, this is always interesting, because I do think if you're doing microservices, you have to do some extent of DevOps, which we do. You have to do some extent of support. But I'm really resistant to having to support something if I don't think it's something we can support. So you have to be looking and saying, this data store is flaky, and we don't want to be woken up every night because it's flaky. We're going to take the time to fix it. It's not enough to write good alerts in the start. You have to keep looking at them. And one thing you have to do is, if you didn't do anything, get rid of the alert. And this is something that my developers really struggle with. They're really worried that if they get rid of the alert, that we might not find out about something. My experience is we tend to find out from many different sources when things go wrong. So I spend a lot of time going, right, that alert, we didn't do anything, delete it. And you need to look at it, because things change. We recently moved our runbooks from one location to another, so all our alerts are pointing to a location that now redirects somewhere else. Well, probably we should fix that up. And it's good to get people outside the team or new people on the team to review them, because they might point out that you've made assumptions about what people understand by reading this alert. So that's really handy. Obviously, if you didn't get an alert and things went wrong, you had to do something. So, you can look at what happened and say, well, what would have told us? Oh, well, the ratio of successful to failed alerts, responses would have told us. And I think making sure that alerts would fire is part of fixing whatever issue you've just got. And it might, in fact, often the case for us is not that you need to go and write a new alert, it's that whatever flow of code just happened didn't trigger the existing alert. And this will be things like a microservice that returns 200 even though it actually failed. If you make it return the right status code, the alert will catch it and you'll be fine. It's harder at the system boundary. So we've got several content management systems that tell us when they're publishing something. And one of them just stopped telling us. And it took us days before we noticed. And we asked them if they could add some monitoring to check that they're sending that notification. But we also wanted to do something ourselves. But then you start thinking about it, and you think, well, our publishing is kind of intermittent. And we could say, tell us whether there's been a publish in the last day. But I can guarantee you that alert will fire on Christmas Day, because no one's publishing stuff on Christmas Day. So you want to be really careful about these kind of belt and braces things, but you do need to know what's happening in the things that come into and out of your system. You do need to know if an alert would stop working. I improved some logging because it was really badly worded, but it turns out all our alerts for publishing failures relied on this really badly worded logging. It would have been nice if there'd been some kind of a test that would fail when I tried to run tests on the code to say, you know what, this word is quite important, we're using it. We haven't done this, but it would be nice. You need to deliberately break things, because you think that your alerts will work, and then when you try it, it's never quite as simple. So FT launched a new website around October last year. In the run-up to it, we spent some time practicing because we knew we had first-line support that would have to support our system. They didn't know it very well. And we wanted them to be able to do the basic stuff of working out it was our problem, turning things off and on again before escalating it. So we did some drills, and we did it in production, because I actually think it's much better to do it in production, because people pay attention to that. So I talked to our editorial team and agreed that I could have a 10-minute slot where I would deliberately break their ability to publish stuff. They were all in morning conference, it was fine. So I just went down and sat with them and turned some stuff off. And I told the people who led the teams that were going to get the alerts that this was going to happen. The first time, my team fixed it in a minute. I had to tell them to back off and leave it. So we had to warn everybody, let the first line deal with it. But the second time, nothing went red. And I was kind of like, okay, I really thought that was going to go red. So we realized our alerts were not giving the right information. And we've also, in the past at the FT, when we weren't running so much on AWS, we've deliberately turned off a data center. So we've told everyone it's going to happen, we've got everyone to come in on a Saturday, and we've turned something off. And that has been incredibly good, because you think you're resilient, and then when you actually, 2 days beforehand, you suddenly go, I wonder whether there's a dependency there that we can't get around. And we found quite a lot of things. Like we were like, oh yeah, publishing will be fine, apart from the fact that somewhere deep in the Kafka library was a timeout that was going to wait 10 minutes before failing, and so therefore editors would be stuck 10 minutes unable to do anything. It's not good. I am sure people have heard of the Chaos Monkey. Netflix also have an entire simian army for just testing resilience. And we have something called the Chaos Snail. And it's called the Chaos Snail because it is smaller than a monkey and because it's written in shell. And I didn't write it, but I think that's just brilliant. And it just basically runs as root on a VM and kills processes, logs somewhere else what it did, and you can work out whether your alerts fail. And that's pretty handy, and I think it's really cool. Things are going to change. And actually, that's the benefit of microservices. You can make lots of changes independently without affecting everybody else and get it out there really quickly. I mean, we deployed to production, my platform deployed to production 1,400 times last year. The previous platform went 12 times a year. It's 150 times as often that we're releasing code. And the chances of us having a problem when we release that code is greatly reduced. I mean, the 12-a-year ones, I think we'd probably have 3 a year that would be a nightmare that might involve rolling back and horrendous pain. Now it's like, well, maybe we've had 3 in the year where we've had to roll forward. 3 out of 1,400. But that means you need to be constantly paying attention to the stuff that's being sent out, because out-of-date information is really painful. So we spent an hour trying to work out why one part of the website had stale content. We just couldn't work it out, and then eventually we found out that the website team had switched from one API to another, but they hadn't changed the documentation. So we thought they were using our API, and they weren't. It's good if you can automate updates, because clearly automation always makes things easier. And we're looking at having our runbook information held with our code so that we can, basically, as we deploy the application, we can call an API to update the runbook. My ideal scenario would be to be able to run tests to check that that's still good. So perhaps we have something which documents our API endpoints, and we run a test. So if we've removed an endpoint and the documentation still refers to it, the test will fail. And I think that's powerful. And you need to find ways to share what's changing, because we've got maybe 35 developers and testers, and we're working on lots of different things. So you're never going to know everything that's going on in a microservices environment, I think. And so you have to think about how you tell other people about it. So we do lots of showcases. We basically do walkthroughs for any big new bit of functionality. We're constantly sending updates of what we're working on to try and make sure people know what's going on. So in summary, to avoid having too many alerts, you need to think about it right from the start. So you need to build in the things that will make your life easier. You need to work out what matters and concentrate on that. You need to continue to cultivate your alerts and not be afraid to turn them off. That's the hardest thing. So microservice architecture does let you move fast, but there is an associated operational cost, and you need to decide whether it's a cost you're willing to pay. And when I say you, it's not just you. You can go, hey, great, microservice architecture, really nice. But if your product owners and your directors and your delivery leads are complaining because you're spending 10% of your time doing operational tasks, you can't do it. You have to basically convince people that you can move fast, but you have to spend some time on all of these surrounding things. And we've been really lucky with that. I mean, the reason that we're spending time now to bring Kubernetes into our system is because we've basically said it's hard to support our handwritten cluster. Who'd have thought that writing it would be a bad idea? But basically, we can spend that time because we've convinced our product owner that this is a good idea. It really helped that I said, hey, you know what? We can actually turn our lower environments off overnight if we use this, because that saves 70% of our AWS costs. So that was an easy sell, but you've always got to have the time to do these improvements. So that's it. Thank you.
We do have over 10 minutes for questions, so I'd love to take a few questions. I'm sure, thanks to Sarah, great talk. Plenty of things to think about if you're running microservices or thinking about running microservices. So anyone, oh, yeah, I see a hand.
Hi. I was wondering about when developers are writing microservices, do you have some checklist that they need to fulfill before they are added to production? Because you have to add information to different kind of monitoring systems, support different kind of logging, so you will never accept them until they have filled it out. Is that something that you provide, or is it just in the DNA of your company?
So there's actually two aspects at the FT. So we have an engineering checklist that talks about the whole life cycle of work. So from everything from do you actually need to build it, could you buy it, through to what you do at the end of life. But it's very light on talking about what happens during day-to-day development, during a system that's in kind of development. We have a checklist in our team too. So we have the general, have you looked at the alerts? Have you updated the panic guides? Have you done a walkthrough? So yeah, checklists. Checklists are really powerful for this stuff. I don't really mind how you've put a health check into something, but I do need you to have done it. So yes, we do, and that works quite well. And our QAs basically are responsible pretty much for making sure that everything on the checklist has been revisited. They're also brilliant at doing the check for alerts. So I think I'd say that across the team, some people are really good at picking up that alerts have got missing information and some aren't. You just use the skills people have got. Does that answer? Yeah, cool.
Any other questions at all? Going once? Going twice? Oh, Chris.
So we saw last week the trouble you can get yourself in if you host your status page on the infrastructure that it's monitoring.
Yeah.
What are you doing about that?
Yeah. So we kind of aren't, because dashing is the dashboard calls our aggregate health check. So the dashboard will go red if it can't call it. So actually we do have, someone is going to know that our cluster's gone down. Yes. We have had problems where things go wrong and you can't even get on to work out what's happening. But we do have enough separate calls in. You know, we have Pingdom calling our health check. So as long as Pingdom is up and dashing is up, we've got two different sources that are calling the same resource on our system and that will go red if something goes wrong.
Awesome. Final offer? If not, that was last minute. Good stuff.
I was interested when you had the example of one database failing, and that's causing alerts from everything up the stack that was affected by it.
Yeah.
And that's kind of caused from an alert storm.
Yeah.
So you obviously don't want that. But how do you make sure that you know that if you've got a problem here, that there's all these other things that could be affected by it?
So that storm is something that used to happen to us a lot because we had just done every service alerted if its response time was too long or if it had errors logged. We removed most of those, actually, and our ideal scenario is to only have monitoring through these services that know about the business functionality. So for publishing, as an example, it's only that publishing monitoring service that should alert if something goes wrong. We might then want to go and look at the status through metrics or through logs, but the only thing that alerts should be that. But it's quite hard to do, so we're kind of in the middle of it. Yeah.
Final offer?
I'm around all day if anyone wants to have a chat.
Thank you once again, sir. Really great talk.
Thank you.